Greetings. My name is Muhammad Aiman bin Muhammad Roslan, matrix number KIB 190030. Today we'll be taking a look at our case study, motion of a car on a straight road through different conditions. Now, in this case study, it's about a motion of a car on a flat straight road. There will be a few types of forces involved on the car and between the car and the surface, which will be mentioned later. Now, in this case study, there will be two different road conditions that will affect the friction force, thus influencing the magnitude of the acceleration. Now, the type of car in this case study will be a hatchback car, the Prodrome IV 1.3 liter. Now, the forces involved in our case study today, I will introduce to you. First is thrust force. Thrust force is a force or a push, essentially a product of the net force of the car, which moves forward, which, according to the formula, force, which is mass multiplied by the acceleration of the object. Next is the drag force. Essentially, the drag force is the resistance experienced by an object. In this case, is the air resistance. Next is the friction force. According to definition, friction force is the resistance of motion of an object relative to another, and in this case, it is between the car itself and the road, which will differ later in the two situations. Next is the normal reaction force. By definition, normal reaction force is the force exerted by surface on an object in contact, which prevents it from going through the surface. Essentially, this force is actually a representation of Newton's third law, which is for every action, there is an equal but opposite reaction, which introduces the next force, which is called weight. Weight is essentially, according to its simplest definition, is the force exerted on the body by gravity. So the opposite of the weight will be the normal reaction force. Now, what is the situation for our case study today? An 80 kg man drives a 955 kg Prodrome IV 1.3 liters on a flat, straight road from point A to point B, once each day for 2 days. He started from rest, and then at point B, the car's velocity was 80 km per hour. We now need to find the necessary forces that were acting on the car. Then, we need to find its acceleration and the time taken from A to B for both days. Now, the conditions: on the first day, it was a sunny and dry day. Therefore, the road was assumed to have a kinetic friction coefficient of mu k equals to 0.7. Whereas on the second day, the road was wet due to a heavy rain. Therefore, it is assumed that it will have a kinetic friction coefficient of mu k equals to 0.4.
Hello, so now I will show the free body diagram of the car. As you can see, this is the free body diagram of the car that we have made it. So, first of all, this is the weight of the car that is located at the center of the car, and the arrow is showing moving downward. At the front of the car, there is a thrust force that we label as Fp, and the arrow is showing moving forward. And at the back of the car, there is a drag force that we label as Fd, and the arrow is showing moving backward. At the front of the tires, there are two forces acting on it. The first thing is the normal force that we label it as N1, and the arrow is showing moving upward. And the other force, which is friction force, that we label it as FF1, and the arrow is showing moving backward. At the back of the tires, there are also two forces acting on it. The first force is the normal force that we label as N2, and the arrow is showing moving upward. And the second force is the friction force that we label as FF2, and the arrow is showing moving backward. So now, there are some reminder notes that we put in this equation. So the first thing is the total of the friction force is equal to friction force at the front tire plus with the friction force at the back tire. So it's equal to friction force 1 plus with the friction force 2. The second thing is the total of normal reaction force is equal to normal reaction force at the front tires plus with the normal reaction at the back tire. So it's equal to normal reaction force 1 plus with the normal reaction force 2. So now, there are some important points that we know from this equation. So the first thing that we know that mass of the driver that we label as mg is equal to 80 kg. The second thing is that we know that mass of the car that we label as mc is equal to 955 kg. So in this situation, we do it on the two different type of road. So the first type of road is the dry road. So we put the value of the coefficient of kinetic friction force which is equal to 0.7. So the another different type of road is the wet road. So we do it on the wet road and we put the value of the coefficient of kinetic friction force, which is 0.4. So next, this velocity is shown when the car is not moving. So we can say it's equal to 0 km per hour or 0 milli per second. So the velocity v will show when the car is moving. So we put the velocity v is equal to 80 km per hour, and when we convert it to milli per second, we get it 22.222 milli per second. So now there are 5 assumptions that we assume in this situation. So the first assumption that we assume is the road is straight with no bumper. So the car can move clearly without any hazard on the road. So the second assumption that we assume is the car accelerates, which is the thrust force is greater than the drag force plus with the friction force. The third assumption that we assume is the car's cross-section area is equal to 5.9 meter squared. The fourth assumption that we assume is the density of air is equal to 1.225 kg per meter cube. And the last assumption that we assume in this situation is the drag coefficient of the car that we label as CD is equal to 0.3.
Hello everyone, greetings. I'm Amiruddin and I'll be responsible for finding the forces in the free body diagram. First of all, let us find the forces involved in the y-axis. Now, as we all know, the only forces involved is the normal force and the weight in the car. Therefore, we can make a summation of N minus W equals to 0. And since the road is flat and no inclination, we know that there is no acceleration on the y-axis. Now, how do we obtain the weight of the car exactly? We need to involve all the masses involved and multiply it by the gravitational acceleration. And how do we obtain that? Well, the mass of the driver is 80 kilograms and the mass of the Myvi car is 955 kilograms specifically. We add it up, multiply it by the gravitational acceleration, which is 9.81, and we obtain the flowing force, which is 10,153.35 Newton, and that is the total weight of the car and the driver. Now, since we know that all the forces in the y-axis can be represented in n minus w equal to 0, we can use the following equation to obtain the normal force, which we then get n equals to w, which means that the normal force is equivalent to the weight, which is 10,153.35 Newton. Moving on. Now, we need to take into account the conditions of the road, which is dry roads and wet road. They will have different frictional kinetic coefficients, which is 0.7 and 0.4 respectively. Now, we are able to obtain the frictional force when multiplying it with the normal force of the car, which is, as mentioned before, 10,153.35 Newton. And for the dry road condition, we are able to obtain the frictional force of 7,107.345 Newton, while for the wet road, we obtain the frictional force of 4,061.34 Newton. Moving on, based on the assumptions made, we know that the formula of the drag force is 1/2 multiplied by rho v square ACD, where rho represents the density of air, v velocity of the car at point B, A is the cross-section area of the car, and CD is the drag coefficient of the car. For all of the following variables, we have calculated it before and we just need to input it into the formula, where the rho is 1.225, the velocity is 22.222 ms negative 1, and the cross section of the car is 5.9 meters square, and the drag coefficient of the car is 0.3. Now, we just put in the values we obtain, and then we will obtain the drag force, which is 535.36 Newton. This is the free body diagram that we obtained, and since we assume that the car accelerates, the magnitude of the thrust force should be larger than the drag force, plus frictional force combined. Thus, the thrust force for both cases is set to 8,500 Newton. And as we can see in the free body diagram here, the normal force is placed above as 10,153.35 Newton, and the weight of the car is placed below in the y-axis as 7,153.35 Newton, because as we know before, they cancel out each other to obtain a net value of 0 in the y-axis, and the frictional force is in the left direction, as well as the drag force, and we know that the total of those both forces, either in dry road conditions or wet road conditions, must be smaller than the value of the thrust force. Okay.
For my part, I will be presenting calculations based on the kinetic diagram of a moving car on a dry and wet road. There are two parameters that we can extract from a kinetic diagram, which is acceleration and velocity, through calculation. Okay. In order to find the acceleration, we need to determine the force acting on the car across x-axis. Based on the diagram, there are three forces acting on the car, which are thrust force, drag force, and friction forces. Okay, now let us see the general formula of the forces at axis. Summation of x equal to thrust force minus drag force plus friction force equal to mass of the driver plus mass of the car times with acceleration. We need to find the acceleration here. Okay, so we just put the information that we have and the value we have. Thrust force is 8,500 Newton minus with drag force 535.36 Newton plus with friction force 7,107.345 Newton equal to mass of the driver, which is 80 kg, plus with mass of the car, which is 955 kg, times with dry acceleration. So the acceleration on the dry road, we get 0.828 meter per second squared. The same goes for the wet road. We just change the friction force, which is 4,061.34 Newton for the wet road. So we will get 3.771 meter per second squared for the dry road acceleration. Now let's move to the velocity. Okay, we know that the car starts at rest. So VA equal to 0 meter per second and VB equal to 22.22 meter per second. Okay, we want to find the time taken from point A to point B on both dry and wet road. Okay, as you can see here, VB minus VA divided by acceleration on dry road, we will get 26.838 seconds. So for the wet road, VB minus VA over acceleration on the wet road, we will get 5.893. So these two are the time taken for the car to go from point A to point B on both dry surface and wet surface.
Alright, so I'm going to summarize what we have seen in this video. Firstly, based on the case study, we know that different road conditions have different friction coefficients, where dry roads have higher friction coefficient, which reduces the acceleration, while wet roads have lower friction coefficient, which increases the acceleration. Then we know that for any car on a flat surface or a flat road with no inclination, we'll have 5 external forces involved. In the x-axis, the thrust force, drag force, and friction force, while in y-axis, the forces involved are the weight and the normal reaction force. Based on what we have seen, this is the free body diagram and this is the kinetic diagram. These are the references used to make this video. That is all from us. Thank you.